This would be your direction or heading that you want. But you have to take care. Always figure out what quadrant you're in, and that will help you not get mixed up. I hope that's clear. Okay, let's see. What I'm going to do here is, well, let's look at number 7. Of course, this is real easy, but in 7, it looks something like this. You have a coordinate system, you draw a vector, and it says estimate the angle. Well, how would you estimate the angle? You would have, I should have had a protractor with me, but hopefully you have a protractor. You put your protractor on here and you measure this angle, and it's probably going to be something like 135 degrees as measured from a protractor. So make sure when you go into your test that you bring your protractor with you, because you will likely need it for measuring angles and drawing angles. Okay, at this point, I'm going to go right over to page 104. Okay, and we're going to look at number 1. And we want to add 2 vectors, and the 2 vectors look like this. Here's the A vector, and here's a B vector. Okay, so remember what we do. We just take the one vector and we slide it. Doesn't matter which one we slide, so it's going to be easier for me. So I'm going to take this vector and slide it down here, and I'll do something like that. So that's the A vector just slid down, and then I draw an arrow from the tail of one to the head of the other, and that would be C. So A vector plus B vector equals C vector. Okay. Now if I say, now question number 2, that's A plus B. Says, question number 2 says to subtract the B vector, subtract the B vector. So now I want to say, okay, what's A minus B? Now I want to do A minus B. So how do I do that? Okay. The way you do this is, if this is B, then minus, if B is oriented like this, minus B is just the opposite. So minus B would be a vector from here, be the head. I just flip the vector around. That's all I do. That now I have minus B. Instead of B, I put a minus sign. Now I have minus B. It's just heading the opposite direction. Okay. Now I take this arrow, this vector, and I slide it up to this one. So if I do that, I'm just going to estimate this. I slide this up, and I would get something from here, and it would go up about like this. That's minus B. So basically, what I'm doing is I'm taking A, and I'm adding to that a minus B. Do you understand? I just form the minus B vector, and then I add the minus B vector. And the result is from here, tip of one to the tip of the other, to here. So that's now C, the new vector. I take A and I add to that a minus B. Okay? Hopefully that's clear. All right, let's do number 3. Or problem number 3. Problem number 3 says the velocity of the plane pictured below is pictured below along with the velocity of the wind through which a plane is flying. Graphically show the heading of the plane. Okay, basically the plane is going this way. That's the velocity of the plane, but the velocity of the wind is like this. The velocity of the wind is at a different angle. So these are two vectors and we add them up. In fact, this happens if you've ever flown in a small single-engine plane. You know exactly what this feels like, because you can be going in a certain direction, but the wind's coming from a cross direction, and in order to, especially, you see it especially when you're flying down a runway. If you've ever flown down a small runway on a small plane, you have to, in order to go straight down the runway, you have to tilt or kick your rudder in, and as they say, and you have to kind of fly sideways down the runway in order to go straight down the runway. And basically, it's because of this wind factor. But to answer this question, we just take 1 and we slide it. There's the V wind. So actually, even though the plane is heading in this direction at that velocity, actual travel is this way. The plane is heading this way, but it's actually going in this direction with a little bit smaller speed, magnitude, because of the wind. Okay. Question number 4. Question number 4. Vector A has a magnitude of 35.1. Let's see. Vector A has a magnitude of 35.1 in a direction, meters per second, direction of 215 degrees. Well, if this is x and y, 215 degrees would be in the 3rd quadrant. So it would be something like this. It would be in the 3rd quadrant. So this angle here, you remember all the way to here is 180 degrees. So this angle is 215 degrees. The question is, what are the x and y component? The x component, here's, if this is A, the x component is AX, and the y component is AY. Okay? So, remember, the cosine, this angle here, okay, well, let me say this. I'm just going to write this out and then we'll explain it. Basically, the x component is the AX component is the magnitude times the cosine of the angle. Okay. Now, where does that come from? I wrote it out quickly, but where it comes from is, remember that the cosine of the angle equals the x component. Remember it, x over the hypotenuse, or in this case the x component is the AX component. The hypotenuse is the A. This length here, from here to here, we're going to call A. So that is, the magnitude of that is the hypotenuse. So because of this, we can say that the AX component is the A times the hypotenuse times the cosine of the angle. Okay? So, likewise, we can say that the y component is the A times the sine of that angle. Now, if we use the full 215 degrees, which we should, the sines will take care of themselves. Just be careful and make sure. So, for instance, the A is 35.1 meters per second. Okay, so basically, AX will be 35.1 times cosine of 215 degrees. If I take 250, make sure I'm in degrees, 215 degrees was a cosine times 35.1, and I come out with minus 28.8 meters per second. That's the x component. Notice it's a negative number. It's a negative number. The y component is 35.1 times the sine of 215 degrees. And I plug that in, 215 times sine times 35.1, and I get minus 20.1 meters per second. So those would be the two x and y components of this velocity vector. And they are velocity components. Okay, question number 5. A velocity vector of a car has an x component of 17. It has an x component of 17 meters per second, and it has a y component of minus 11 meters per second. What are the magnitude and direction of the velocity vector? So in this case, the problem is giving you the x and y components. This is the x-axis and a y-axis. We have plus 17 over here and minus 11 here, so the vector, what quadrant is that in? This will be the fourth quadrant. So we know we're going to have this angle. We could talk about the angle this way, all the way from x-axis, but we also could give it a negative angle. Either way, the magnitude, okay, is simply the magnitude of this vector. We'll call it v. Will simply be 17 squared plus 11 squared using the Pythagorean theorem, the square root of all of that. So we get 17 squared plus 11 squared, and we take the square root of that, and then we get 20.2, and that's the magnitude, meters per second. So that's the actual velocity, that's the actual speed. The actual speed, 20.2 meters per second. But what about this direction? Okay, what I'm going to do right now is I'm going to ignore this negative sign and just say that we know that the tangent of this angle here is the opposite over the adjacent, or y over x, or y over x, or it's 11 over 17. So that means that the angle is equal to the inverse tangent of 11 over 17. I do 11 divided by 17, and I do inverse tangent, and I get minus 32.9 degrees. Well, actually I get 32.9 degrees, but I interpret this as saying it has to be a negative number. It has to be a negative angle. So I would say negative 32.9 degrees. Now let me say something. I'm going to tell you when it comes to homework and tests, whenever you have a magnitude and a direction, I'm going to give you a really good way to write these down. The way I want the answers to be written down would be the magnitude, draw a little thing like this, and then the angle. Okay, so when you write the answer down here, what I would want would be 20.2 meters per second at an angle of minus 32.9 degrees. So that would be your answer, and you would write it this way. So basically, whenever on a test or something like that, when you want to write down the magnitude and the angle, do the magnitude, draw this little corner here, and then put the angle right here. This actually, by the way, is something engineers typically do, especially electrical engineers, magnitude and angle, and we'll talk more about that later when we talk about things like phasers, but not the zap phasers in Star Wars, but actually the original definition of phaser was a term used in electrical engineering, and it was the phaser was indicated. It's a little bit more complicated than this because it gets into complex numbers, but it was indicated with the magnitude and angle, and it was written in this way. So actually, when you write this way, you're writing your answer in the way an electrical engineer would write it. Okay, that's that question. Okay, question number 6. Okay, vector A, in fact, I'm going to write it in this notation right now because it's a very quick and efficient notation in which to write these vectors in. Vector A has a magnitude of 31.1 meters at an angle of 160.0 degrees, and B, vector B, has a magnitude of 11.4 meters at an angle of 290 degrees. Notice how efficient this way is a really great way to write a vector, magnitude, and a direction. It's very quick and easy. So the question is, what is the sum of these two vectors? Well, we could add these up from a geometry point of view, but in this case, they've given us hard numbers, and so we want to add them up in an algebraic way. So what's the only way to do this is to break these up into their components. So we say this. We say A, the vector A, is equal to AX plus AX plus BX, AX plus AY in the Y in the Y. In the Y, we have AX in the X direction, AY in the Y direction. What is AX? AX is, it's A, the magnitude of A, times the cosine of the angle in the X direction, plus the magnitude of A times the sine of the angle in the Y direction. Okay, so I'm just going to go ahead and put these numbers in. 31.1, the A vector, so this becomes, and it's 160 degrees. The angle here is 160 degrees. So I would do 160 degrees cosine times 31.1, and I get minus 29.2 in the X direction, plus sine of 160 degrees sine of that times 31.1, 10.6 in the Y direction. All of this is in units of meters. Okay, likewise, the B component, the B component will be just the same kind of thing. It will be the 11.4 times the cosine of 290, I'm just going to write this up above it, plus 11.4 times the cosine of 290. So just to separate them here, this is A, so B will be 290 cosine times 11.4, I guess 11, oh, of course, no, 290. Whoops, I didn't do that quite right, I'm sorry. 290, I think I did 270. 290 times 11.4, 3.9 in the x direction. Check me out, make sure I'm getting these numbers right. 290 times sine, or sine of 290 times 11.4, and that's a minus 10.7 in the y direction. So we simply add these up. We add the x components and we add the y components. So we have 29.2, a negative 29.2, plus 3.9, and we get minus 25.3 in the x. So we'll call this C. And we'll have 10.6 minus 10.7, or minus 0.1, minus 0.1 in the y direction. Okay, so now we have C, which is broken up into the x and the y, but we still have to get the magnitude. Okay, I'm going to erase this right here. Okay, so the magnitude of C is simply this squared plus this squared square root. So I'm going to put this right up here, just so to make it higher for you. The magnitude of C, called the magnitude of C, is 25.3 squared plus 0.1 squared square root of. And this is going to be very close to that number, 25.3 squared plus 0.1 squared, which isn't very much at all, square root of, and we have 25.3. In other words, this barely contributes much at all. Now the angle we have to be very careful of. Notice what quadrant we're in. Draw a little diagram. X is minus way out here, and the y is minus. So we're just barely into the third quadrant. Okay? So this angle is going to be into the third quadrant. So we want this angle here. Okay? So what I'm going to do is I'm going to blow this up a little bit more. Just so you can see this, we have an angle like this. Here's the x. We have it way coming out here and then a little bit over here. So I want this angle here. So the tangent of this angle is the y divided by the x. So it's 0.1 divided by 25.3. So that angle is the inverse tangent of 0.1 divided by 25.3. Whoops. That angle is, if I use my calculator, 0.1 divided by 25.3, inverse tangent, and I get, whoops, I flipped it to radians. Let me flip it back to degrees. I want it in degrees. 0.1 divided by 25.3, inverse tangent, and I get 0.23 degrees. Well, I know that's this little itty bitty angle here. But what do I have to do? I have to add 180 to that. This angle that I really want is 180 degrees plus 0.23 degrees, or it's about 180.2 degrees. So my final answer, the sum of A plus B is C, which is a magnitude of 25.3 at an angle of 180.2 degrees. Hope that's clear in how you handle that. Okay. Let's see. The rest of the questions are actually all kind of similar. What I'm going to do here, I just did 6, 7, 8, 9 are kind of similar. What I'll do is let me just jump down to question 10. How about that? And question number 10, since that, I don't know if it's the hardest, but it's the last one, so I'll go ahead and do that. Question 10. Okay, a man rows a boat across a river. The man can row at a speed, so the man rows at a speed of 3 meters per second and heads due east. So if, let's say, X is east, and the man heads due east, and he has a velocity of 3.0 meters per second, and he's heading due east. Okay, the river current has a velocity of 1.5 meters per second, heading at a heading of 135 degrees. So the river is doing this. The river is about half his velocity, 1.5 meters per second, and this is at an angle of 135 degrees. Okay. The question is, what will be the final velocity of the boat? Okay, this is the velocity of the boat. This is the velocity of the river. So the sum, the actual, this is the heading of the boat. The velocity of the boat, the actual velocity that's heading, that the boat really goes in, will be the velocity that the boat thinks he's going in, plus the velocity of the river. So we have to add these. Vectors up. So really, this is just another exercise in basically adding vectors. So the velocity of the man, we'll call it, is he's heading in a 0 degree. So really, from a component point of view, he's going 3 meters per second in the x direction, and he's not going anything 0 in the y. Okay. The velocity of the river is, I'm going to come up here and I'm going to say it's the 1.5 times the cosine of 135 degrees in the x direction plus 1.5 times the sine of 135 in the y direction. Okay, so I use my calculator, and I say 135 cosine of 135 times 1.5, and then I get minus 1.49 in the x direction, meters per second x direction. The y is 135 degrees sine of that times 1.5, and I get 0.13 in the y direction. Now I'm going to add this. I'm going to erase this just temporarily. I simply add these two. Okay. I add these two, and I get, this is simply 3 minus 1.49, and I got 1.51 in the x direction plus 0.13 in the y direction. Okay, so if I would draw this from a quadrant point of view, I have an x component and the y component. Okay, so I'm definitely in the first quadrant. We have a plus x component and a plus y component.